Apparently there are planets in Saucers.Space. Not quite. These are artificial planets, comprised of a number of AI UFOs. In this video, I'm going to talk about how we got here, and then I'm going to show you the most satisfying thing ever, destroying all of these UFOs with Bomber. Believe me, it's really satisfying, so stick around for that. It turns out that building AI and the algorithms involved with AI are quite complicated. They're quite hard to build. Saucers.Space uses a variation of A star. The A star algorithm, simply put, is a graph traversal algorithm that allows the AI to find the fastest way around the map. So that means there would have to be points of interest, these are called waypoints, throughout the map, and given any waypoint, the AI should be able to find its way to any other waypoint. Now, any 6th grader could describe this algorithm in a rudimentary way. Given any waypoint, look at all the other waypoints available, and then find out which the closest one is that's not blocked, and then go to that. But it's a little bit more complicated than that, because not only are we trying to find our way across the map for each AI, this needs to be done frequently, and it needs to be done efficiently. So we have to have an algorithm that runs efficiently, and that's extremely important because of the number of AIs that are on the map. And if it's not done efficiently, then that'll just leg up the server. Now, the algorithm A star handles all of this. It's very efficient, and it's even used by professional mapping software and even autonomous cars. And if you've watched my previous videos, you would have seen that I've worked with A star before, and I've actually built an implement of it that allowed an AI to traverse a graph and find its way around. But that was different because I set the waypoints manually. I manually placed them in key locations on closed loops, and that was very easy to do, albeit a little tedious. But this is going to be a little bit different. In Saucers.Space, I want all the waypoints to automatically generate based on the map. There are a lot of advantages to that. For one, there's going to be many more waypoints on the map in total. That means that there's going to be more paths that the AI can take. That means that the AI will be smarter. It also means that if I update the map in the future, the AI won't all break if I forget to update the waypoints, and I won't have to come back and set the waypoints every time the map is updated. And if I create new maps in the future or have maps that are automatically generated, the algorithm will just plug into those and I won't need to do any additional work. And I'm only one developer, so anything that I can do to automate the workflow of this game really, it's a lot of upfront work, but in the long run, it will save me a lot of time and allow me to build an incredible game experience for the players. Now, a few days ago, I made the naive claim that I would have AI pathfinding done within 24 hours. And I sort of did. I had the waypoints getting set up automatically, and I had AI that was able to go from one waypoint to the next without backtracking. But it wasn't good enough to find its way around an obstacle. And then, of course, another problem is that they were getting caught on edges, and they were getting caught in closed loops. And that was actually a waypoint path generation bug. But I think what I got caught on is a lot of optimizations, and also debugging things is quite hard. Let me tell you exactly how this algorithm works. First of all, I add all the obstacles, like the structures and everything. Not the asteroids. The AI are too stupid to navigate their way around asteroids. So that could be a planned feature in the future. But right now, they just find their way around structures and obstacles, permanent obstacles. And then after all the obstacles are down, I actually generate the waypoint graph based on where the structures are. So at every corner, I'll add a waypoint where the AI thinks that, well, this might be an important point because it's the corner of a structure, and being the corner of a structure means that perhaps this is like a corner that the AI can traverse. It can go around the corner to get around the corner, the obstacle. So that was the idea with that. The next step is that sometimes a lot of waypoints are kind of close together. So they're just situated so close together that they really should be one waypoint. So the algorithm has to merge waypoints that are close together. Not all waypoints that are right beside each other can be merged. There might be an obstacle in between, so that has to be checked. And in the main capture the flag map, that takes the number of waypoints down from about 330 down to 230. So it's a pretty significant drop. And then the next step is just to take every waypoint and then search through every other waypoint and find out whether there is an unobstructed path in between the two. And then that will tell any future AIs that that is a possible road that they can take to get from one waypoint to the other. And this all happens on map generation. It's not happening in real time as the game plays. In fact, this is a very process-intensive process. Unfortunately, this generates a lot of paths that go through windows, so another algorithm has to sweep through every single path and make sure that it has enough padding for a ship to fit through that path, so that if the path goes through a window or something, then that path will actually get pruned out by the algorithm. The next step after that was to break down paths that overlap, and I think I might actually skip this one for the next update because it's just taking way too long to debug. It's a very complex process, and it greatly increases the amount of time needed to even start the server because so many different paths need to be checked against every other path, and then it breaks down into smaller paths, and then all of those paths have to be checked. So it actually takes about a minute to start the server when this feature is turned on. And it also adds like 200,000 new waypoints that all have to be merged and so on in the proceeding steps. In theory, that would lead to smarter AI, but my time right now is priceless, and this is having diminishing returns for me. The next step is to look for waypoints that are right beside paths and then merge the waypoint into the path as if it were an intermediate step. All this does is it makes it a little bit easier for the AI to make a decision as to which path to take to get to their destination, because there will be fewer options. Then I run the algorithm that merges nearby waypoints again, and then the final step is to sort the waypoints based on their position in the map into a structure called an AABB tree. And the reason I do that is so that the AI will be able to easily find the waypoint that is closest to it. Not really something you want to spend a lot of processing time on when you have potentially hundreds of AIs running on the same server. If you're interested in learning more about AABB trees, I have a video on my other YouTube channel where I talk about them in great depth. So thank you for your patience. If you're waiting for the updated pathfinding so I can move on with the game and build game modes and sound effects and all that stuff, thanks for waiting. This really is not an easy thing to build, but I'm doing the best I can. Now, as for these robot planets, the reason that this happens is because the AI will all try to clump around a single waypoint, and because they're crashing into each other, they actually block each other. This won't be a problem in the actual game because the AI will be aggressive towards each other and will kill each other if this ever happens. Well, I need some stress relief, so let's watch some carnage. It would be hard to overemphasize just how satisfying that is. It's like clearing a clogged artery. Alright guys, hopefully I can get this done soon so that I can move on to Team CTF, as well as the upgrade market. As always, thanks for watching, subscribe for more. Bizorke.